Alright, in this video, I'm just going to go through a little bit of a more difficult example and show you how to assign R and S using the 3 steps that we used in the previous video. So again, I'm not going to write the steps out in this video, but if you want to see the steps that I wrote out, and they're going to be in the previous video. But again, I will say them. I just won't write them out, just in the interest of time here. But okay, so the first thing we have to do, if you looked at my previous video, the first thing we do is that we locate our stereogenic center. So where's our asymmetric carbon? Again, these are all interchangeable words. They all mean the same thing. So where is our tetrahedral carbon? Our stereogenic center, in other words, our asymmetric carbon, our chiral carbon. Where is that chiral carbon? Again, these are, just to reiterate, these are all words with the same thing. They're all just interchangeable. So our chiral carbon is going to be right here, right? Again, so that is the carbon that has 4 different groups attached to it. So I'm just going to remember them here just to point them out. This is our first group, second group, third group, and fourth group. So this carbon here is connected by 4 different groups. Again, these aren't the priorities yet. I just want to point out that those are the 4 different groups, and that's why we have a tetrahedral center there. Because in some problems, they'll label stereochemistry, so they'll add dashes and wedges. But if you look correctly, that carbon necessarily isn't a tetrahedral carbon. It's not necessarily a chiral carbon, because sometimes they will have 2 of the same groups and they just add the dashes and the wedges there to try and trick you. So you always have to check for 4 different groups. Make sure you have 4 different groups before you assign R and S. Alright, so I'm just going to do that right there. Alright, so let's go ahead and get started here. So then, after we've located our chiral carbon, now we have to assign priorities. And how are we going to do that? Remember, that's going to go by atomic number. So we have to start listing out all these atoms in order of decreasing atomic numbers. So which one of these is going to have the highest atomic number? So I'm going to look at our hydroxyl group right here. Again, this is our hydroxyl, and that is directly connected to the chiral carbon. And what is directly connected to the chiral carbon? It's going to be the O and the H, right? I'm going to list that out like that, like so. Now I'm going to go here. I'm going to go to my methoxyl group here, to this CH2OH. And so what is directly connected to that tetrahedral carbon on this CH2OH group over here? And that's going to be carbon, followed by oxygen, followed by a hydrogen, right? And again, I'm going in order of increasing priority. Excuse me, I'm going in order of atomic number. However, we always have to list what is directly connected to that carbon first. So in this case, we have 2 hydrogens here, 2 hydrogens there, like that. But this carbon right here, so that carbon right there comes before the oxygen. So that carbon is connected to that center before it hits the oxygen. So that's why we have to list out the carbon here. That's why I'm listing out that carbon first, is because you have to list it in order of attachment. So that's our order there. It's going to be CO followed by H. All right. Now on to the left side. So this formal, it's called a formal group. This formal moiety here. So, or otherwise known as an aldehyde. So this part right here. So what is directly connected to that chiral carbon? And it's going to be carbon first, followed by 2 oxygens. And if you saw my previous video, I explained why we listed as 2 oxygens. And the reason for that is very simple. It's because we have a double bond. So when you have a double bond, you list the atoms twice. So that would count as 2 oxygens. And now we go ahead and we're going to go look at we go ahead and look at our alkyne. So let's move on to our alkyne down here. And so again, what is directly connected to that chiral carbon? It's going to be a carbon, obviously, first, followed by 3 more. So because we have a triple bond, you count it as 3 carbons. However, you don't have to list them. You don't have to list them. You don't have to list all 3 because we really only need, we only need 3 atoms here because that's what's going to help us determine the priority. We can already start assigning priority just by listing out the 2 carbons like that. It wouldn't really make any difference if we listed all 3. So let's go ahead and assign priority. So looking at each atom here, looking at the first atom, which of these atoms has the highest atomic number? And if you're thinking oxygen, then you are correct. So oxygen has the highest atomic number here. Its atomic number is 8. So that's going to be our first priority. Again, we are not looking at functional groups here. We're not looking at the groups. We're looking at the atoms that are directly attached to the chiral center. Do not think functional groups. If you start looking at functional groups, you're going to get these wrong because then you're going to go by atomic weight. And we are not going by atomic weight. We're looking at the atoms, the individual atoms. So that's why we have to go by atomic number. So oxygen is going to be group 1 right there. All right, so what's next? So it seems like we have a 3-way tie. We have a 3-way tie here. We have this carbon, and this carbon here. So what's going to be our next group then? So then now we move on to the second atom. So the second atom on the list in each of these groups. So here we're going to have a carbon, we have an oxygen, and we have an oxygen here. So it seems like between the aldehyde group and the CH2OH, we have another tie. So now we go to the third atom. And the third atom here is going to be the tiebreaker because our third atom here is going to be an oxygen on the aldehyde group, and on the CH2OH we have a hydrogen. So obviously the oxygen beats the hydrogen, and so we're going to go with that as our second priority because the oxygen is of higher atomic number than that hydrogen there. Okay, awesome. We've assigned our second priority. Now what's going to be our third priority? So our third priority is now we need to decide between the CH2OH and the alkyne, and we've already listed them out. So we're gonna go. We're starting off with them back again with the first atom. We have carbon here, and in this case we also have carbon. However, if we go to our second atom, we're gonna get oxygen here, and in this case we have carbon. So oxygen beats carbon, therefore the CH2OH is going to be our third priority. And by default, that leaves the alkyne as the fourth priority here, as the fourth priority. So again, this is the way you assign priorities here. If you started looking at functional groups and took the atomic weight into account, again, you would get these wrong. I remember working a problem with a student I was helping once, and they assigned the alkyne as the first priority. And I asked the student why. Why did you? I was just trying to gauge as to what was their thought process for that. And I asked the student why. Why did you assign the alkyne group as your first priority? And the student responded to me because it looks like the largest group on here. And again, if you cannot make that mistake, especially on an exam. That's going to wreck you on an exam. So remember, we're not looking at functional groups. We're looking at individual atoms attached directly to the chiral carbon. All right, so those are going to be our priorities. Our hydroxyl group is going to be number 1. Our aldehyde is number 2. The CH2OH is 3, and the alkyne is 4. Okay, so let's go ahead and move on to the next slide and see how that's going to work out. So we have 1, we have 2, 3, and 4. Now our third and final step is to assign RNS. So let's assign RNS. So if you looked at my previous video, there's a problem with this. What is our problem with this? The problem with this is that the fourth priority is not pointing towards the back. We need the fourth priority to be on the dash if we're going to assign RNS. Remember, the only stipulation in order for us to be able to assign something, designate something R or designate it S, the last group, the last priority must be in the back. If it's not in the back, this is not going to work. You can't assign RNS if the last priority is not in the back. So how are we going to put it in the back? So what we're going to do is we are going to switch whatever priority is on the dash with the last priority. And so in this case, we're going to switch the first priority with the fourth priority. Again, the reason for that is because we want the fourth priority in the back. So now I'm going to have my fourth priority here and my first priority there. Okay? And now we have our fourth priority in the back, and now we can assign RNS. Now we can designate this RNS. So what are we going to do? So now we just figure out if it's RNS. So we go ahead and follow our priorities here, and it looks like we have something that is clockwise. So I'm going to say that's R, but because we switched the priorities, we have to switch our RNS designation. So now it's not R anymore, it's actually S, because we switched the priorities. So make sure you remember to switch your R to your S or vice versa if you're doing it this way. But again, this is 100% foolproof. Trust me, you will never ever get another problem wrong if you do it like this. This is a foolproof method. It's a systematic method in case you're one of those people that is not gifted and can't do this in your head. For example, me, I could never figure out how to switch the atoms in my head. It was just too much of a brain tease for me, and I needed a systematic, foolproof method. And I discovered this, and it's worked 100% of the time. It's never let me down. I've gotten them all right ever since I started doing it this way. Again, it'll always work. I promise you. I guarantee it. Thank you so much for watching this video. Stay tuned for the next one. I'm going to do some more problems having to do with stereochemistry and enantiomers and diastomers and things of that nature. So go ahead and stay tuned for that. Thank you so much.